Okay, so we'll start our assembly. Do the file new this time. We have the assembly inch that we created, and we're going to bring in the hex, and we'll just let it go origin to origin and have the fix in front of it. Next piece we'll insert, so this really isn't going to take too long. Existing part in assembly, we'll bring in the screw. Let's see, the rotate context should be showing up somewhere, but not seeing it. If you have the little box, then we would rotate about Y. And oh, I'm still looking at it for 2021 apparently, so got to remember to start hitting the right mouse button to rotate around Y. All right, so that gets us a little better into position. So prior to 2022, little box would pop up with the angle and the direction of the rotation, and we just select out of it. So we're going to place concentric, and this is going to be able to move. And then this being the first real item of interest to perform the mate, we'll come back after we insert the handle. So insert component, existing part, and bring in the handle. Go concentric. And picking that edge, face, coincident, we have that in place. So this being, the screw being able to move freely, realistically we have twice as much thread as we need. And as I mentioned, the manufacturing portion. So let's go ahead and add. I'll leave to make sure that I have enough geometry there. So going through the mates, I don't really have anything. Could do a distance mate, possibly to look at the interference, but since nothing really going on there, I want to add one of the mechanical mates, which is to apply a screw. So if we do distance per revolution, that would be the pitch, 1 divided by 18. Or we could do revolutions per inch, which would be 18. So let's go ahead and put that in there. And we'll accept it. And now, when we go to move it, we're going to have to turn this 18 times to make that that location. So sometimes that can be a little bit annoying. And also, this is more towards the dynamic, not really the static portion of our geometry. So if I do put a parallel in here, let's see, if we were to grab the front plane, oh, that was the handles. Let's go to the screw, go to the front plane and to the, I guess, the right plane. Even though I could make those coincident, I would probably want to go parallel or perpendicular because it's easier to identify in the list. We don't use those quite as often, and I just make that a kind of a flag to work with. So that makes this now static. It's not going to move. And because of the screw mate, it can't rotate. So I would either have to suppress the screw mate to have it move back and forth, or whatever position it was in. Or if I unsuppress that and go to the parallel, then now it's able to move again. And then the last one of interest would probably be, let's see, we have a distance from there to there of 0.31. And let's see, does that work out? would have to stack those up. So let's just measure it on the other part. I was looking at the drawing for dimension, since we don't have one of those direct. 0.32, so a little bit longer. So if I was to add a distance mate, and we can do that with the selection, so select and control select. First one is going to be the distance, second one is a limit distance. So its current position is 44 thousandths, and the min or the max could be 0.32, and the min would be 0. Okay, so we're going to see what that looks like. Parallel is still suppressed. For this example, I'm going to suppress the screw as well. There we go. All right, so need to reverse because we're on that interference. So let's edit that again. And we want to flip the dimension. All right, so that's able to move back and in, and we look at the engagement. I'm going to measure real quick to see how much. Oh, don't want the mate. Let's just go ahead and pick the face. So really we're about 3/8 longer than we need to be, other than keeping your hand away from the hex. I think the engagement's good there, 5/16 to for ½ inch across those faces, about 1.5 times the diameter of the screw. So mechanically that should be pretty good. And then its current position, if I unsuppress, then now I would have to turn this 7 or 8 times to get it to position. And if lastly we unsuppress, then it doesn't really go into conflict with the limit. It's within that range, and it doesn't go into conflict with the screw. It just says now it can't turn. All right, so we've got our static. This would be a place where be a good time to save our chain breaker. Make sure we're in the correct folder. So if I want this to have a dynamic, then going to the third tab, to the configuration, right-clicking on the very top, adding the configuration, this can be my dynamic. All right, and these are optional. Making you aware of some of the tools that you have available. And I don't want the origins, so I'm going to turn those off real quick. So the little blue dots go away. And we come back over here and I can look at the list of mates as opposed to expanding out the mates and identifying them within the group. Now, the minus on the chain handle will be because of the concentric. So in this case, I want to lock the rotation. I wouldn't want to lock the rotation here because we've controlled that with the screw, the parallel, limit distance, all those fun things. All right, so for this one, and we'll check and see what happens if I go back to the default. Chain handle is still good. The concentric is still locked. So yeah, pretty much gives us our assembly to where we have one that's stationary, a static configuration, and then one I can see how it moves. And then the only real concern there is when I switch back to the default, it's going to kind of stay in that same general area. So there is the possibility that the assembly would, in the assembly drawing would move just a little bit. Let's go into our exploded view then. Now, in this case, the pin, if I wanted to include the pin in the exploded view, because it is part of the screw model, that's not going to be as easy to achieve. So if that was my intent, then I probably would have made it a separate item. And then just if we'd made that mid-plane as well, done the mate to the plane of the screw. All right, so we'll adjust that just a little bit. Done. Okay, so not a lot there for the explode either. File, new, and we'll go to our landscape. We'll bring in the chain breaker, so since we're in that one, I just want the isometric view. It's checked for the exploded state and the exploded view, and then we can just accept it. If we use the view palette, we'll need to make sure to check it in the view palette, and it's showing the current dimetric, trimetric, isometric. I just like to have that exploded, unexploded view available. Scale-wise, we can go to 1:1. I think we'll have enough room there. And pretty much we have alignment, which, yeah, we'll go ahead and break the alignment. So if I right-click on that view and go to its alignment, I can break the alignment and then have a little bit more to play with there. Inserting the balloons under the annotations, we'll auto balloon. There's 3 parts, so we'll line them up. Kind of have that tendency to go to the side of the part. Let's see, that one looks okay. That one's a little bit confusing, so I'm going to pull it over to an edge. That number 3 is okay. And then we'll right click, insert the table, and we're putting in our bill of materials. Defaults back to the standard. I need to go find, actually I need to add the template location for my simple. And if you use the default, that's fine. There's nothing wrong with that. I've just simplified it and saved it back to our cloud location. All right, I'm going to use the view palette, and we'll go to the hex first. And we can bring in a right side view. We'll project. And we need to think about those section views, because those are going to line up as well. Now I want an isometric. Will the top view give me any additional information? So at this point I'm thinking, we didn't get much in the way of a top view, so I think we'll go with those. We're at 1:1. We'll see about a 2:1. That's probably going to be a little big once we get the section views. If I make the isometric view back to the 1:1, I can control it by itself. All right, and the center mark for the hole comes in. And then let's go ahead and set up the sheets, and then we'll come back and set up our details as well. So here's where it gets a little interesting with the screw. If these are separate parts, then there is nothing really to select. So if I bring this in, let's go ahead and bring in the front view, and we'll create a right side view and accept. Oh, I didn't let it finish. Oh, did that a little bit quick. It jumped back out. So we're on sheet 3. So what I wanted to illustrate is that when we go over and select the bodies, I can pick just the item I'm interested in for that body. And let's see, if I delete that one out and we go back into the projected view, that one should come out without having to do the body. Oh, and I guess I still need the isometric view. Okay, so we'll get it into position, accept, and place. All right, so if we do the same thing for the pin, I can bring in the front view. Yeah, it's not going to hurt. I can always manipulate that with bodies. We'll go in and select the body for the pin, drawing view, projected view, and then accept it. All right, we'll pull the alignment. And then last one, drawing view, model. If we go this direction, I need the handle. And for the handle, we'll do the create multiple views. And actually, this is where the view palette would be a little more effective, is based on the orientation. If I had, if I'd also checked the right view, or if I go back and change it to the top view, then when I bring out the projected view, I'll go ahead and get that that right view. All right, so yeah, the isometric doesn't quite line up, but I like the orientation. Okay, so I'm going to leave it. Okay, so going back to the hex, we had a section view. So if I go back to the drawings, we find the section view. Don't really have to attach it, but if I find a relation, it's less likely to move unexpectedly. So if we go, that direction's not going to hurt. I think as maybe a general rule, I like to have my detail views lined up in the same direction. So let's go ahead and create the B view, and we'll line it up to that one. And go ahead and place it. So that makes the drawing a little bit tight, maybe a little bit on the cluttered side, but I think we'll go with that for now. I want a couple of more center marks, so apply one there, apply one there. That one's okay. And we can start looking at our dimensions. So this is where it gets a little more interesting, is once we start putting in the smart dimensions. Well, it's pretty much reproduce what was there to start. And I'm going to go with the baseline dimensions rather than the chain dimensions. So I'm okay with the 60 thousandths on the flats, but we'll have to see what this does as far as a stack up. So when it gets busy like that, we may want to consider pulling the ordinate dimensions out of our toolbox. All right, we'll stay in that. Could probably have used the bottom view here. Go back to that. But since that worked out okay, and in this case we'll have to add the by 0.125 deep because we're not in the orientation to, oh, and actually instead of the, let's see if we can find the symbol. I'm not seeing the symbol in there, so come back over to the dimension, and instead of Rx, we'll go pick up the depth symbol instead. Alright, so section BB is now kind of in the way. We'll drop that down. And based on our dimensions, oops, went to the wrong side there, so escape puts me back into that. 0.19, radius of 0.19, and it's warning me that I am changing the dimension. Don't really like the direction, so let's see if we can shift that. Sometimes I can hit that little dot. If not, we'll go back to the leaders and pick up. Now that went out to a linear, so now that doesn't look good. So let's stay with the radius and the extension line. Okay, well, if it's going to go that way and pull the extension line around for it, we'll bring it off to that direction. So our dimensions, last one in this group would be the whole call out. And our shape. So yeah, it got a little busy. So let's see, we'll go into annotations this time. Let's see, I want to go with the chain, but realistically in manufacturing this, I'm going to start from this end. This is going to be chucked up in the lathe or in the manufacturing process to turn these diameters. So kind of thinking I want to bring this off of everything off of that end. Okay, and then we go back into diameters. You can pick up those guys. It grabs the cosmetic thread and it finds the 5/16 18 by 2A, so that's all right. And then the 0.33. So kind of got all of those going, and the dimension extension lines going across the radius. So pull that one up. And that did not get a center mark. So if I select, go back into the annotation, pull up a center mark. Let's go ahead and escape out of that or accept it. And then we'll go from point. Not really anything I can do with the dimension, but since I went ahead and created that center line, let's go ahead and add a annotation for the center mark. Maybe we can select the view. All right, so it pretty much says everything's on the same center line. That one's centered, and the distance off of the end. The rest of our numbers come off of that edge. So from a manufacturing standpoint, if I'm making this manually or even if I'm making it with the CNC, I have numbers that are realistic to what I'm generating. So, oh, we forgot the chamfer. So not seeing it there. Oh, we need more dimensions. So more dimensions, chamfer. I always forget if I'm supposed to pick the angle and then the face. So angle and then the face. And then we can come back to our pen. And I know one of these will end up being more dimensions, chamfer. I think it'll look okay over on this side. and angle and a face. And then we'll add the 2 times. So it's denoted on for both ends. And zoom to fit. Oh yeah, at some point I'm going to need to save this before I get all the way through. Alright, so diameter overall and the radius. So that little symbol was the silhouette edge, and it gave us the enough for the geometry. Make sure to save this. Name's okay, and we will call that good for now.